Hello students, this video will walk us through a stoichiometry problem incorporating a eudiometer. Magnesium was reacted with 8 molar HCl. And I know magnesium is a solid at room temperature and pressure. The hydrogen gas produced, single replacement reaction. I'm going to get magnesium chloride, which I know is a soluble substance, and hydrogen gas, and I'll need a 2 here to balance. The hydrogen gas produced was collected over water in a eudiometer. I like to just draw what's going on. It's up to you, of course, to do that or not. Collected over water, I want to make sure I make a note of that, having a volume of 32.85 milliliters at a temperature of 22 degrees Celsius. The barometer read that it's not the pressure of my gas. That is the atmospheric pressure at the time of the reaction, and the water level inside the eudiometer was 18 millimeters lower than the outside. Determine the mass of the magnesium reacted. The partial pressure of water at 22 is 19.8 millimeters of mercury. This is a stoichiometry problem. It's involving a reaction. I'm given information about my acid solution, but ultimately I'm told most about the gas that I'm producing. Can I, with this information, then calculate the amount of magnesium that would have yielded that? Well, let's see. I know my go-to gas law is PV equals nRT, and I know Stoich is centered on mole relationships. Well, can I get moles of hydrogen and then convert to moles of magnesium? Well, I know my temperature, I know my volume, that of course is a constant. This information will help me get the pressure of the gas. So, the pressure of my gas, we know in a eudiometer, we always start with the reference of the pressure of the atmosphere. We've collected over water, so we need to subtract away the partial pressure of water. That's why I'm told this information. And then I have to deal with the height difference. Because my liquid level inside the tube is lower than outside, I need to add my height difference because it's below. This is stronger than the outside. However, I've collected over water. Where this will be millimeters of mercury, I need to divide by the density difference to convert millimeters of water to millimeters of mercury. So, I will take my atmospheric pressure, 742, subtract away the partial pressure of water, 19.8, and add the 18, this water, divide by 13.5. And being careful with significant figures, what we end up getting is 723.5. Now I know for the ideal gas law, this needs to be in atmospheres. So dividing out by 760, I get 0.9520 ATM. Okay, so what I'm going to do is find the moles of my gas. So PV divided by RT equals N, 0.9520 ATM. My volume needs to be in liters, 0.03285. Now, I want to constantly be asking myself, can I use a gas law with this species? And yes, this is a gas. So can of course use the gas law here. And R, 0.08206 liter atmosphere over Kelvin mole. And converting the 22.0 to Kelvin, we get 295.2 mole will be my unit, and I have 0.001291 mole of hydrogen. I could go ahead and start my Stoich here. However, I'm running out of room, so I'm going to put it here. 0.001291 mole of hydrogen. I then can go right to my mole ratio. 1 mole of H2 for every 1 mole of magnesium, and 1 mole of magnesium, 24.31 grams. And I get the answer of 0.03138 grams of magnesium, which a very small yield of hydrogen, we would predict a small mass of magnesium. As always, please feel free to forward me any of your questions.